Conditions to prove a quadrilateral is a parallelogram. So this is section 6.3. The first condition states that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if we know that we have opposite sides congruent, we can then assume the shape is a quadrilateral, or prove that it's a quadrilateral. Second condition, if an angle is supplementary to both of its consecutive angles, then it is a parallelogram. So if we have supplementary consecutive angles, we can prove that it's a parallelogram. Condition 3, if both pairs of opposite angles of the quadrilateral are congruent, then we can prove it's a quadrilateral, or a parallelogram, sorry. So if both pairs of opposite angles of the quadrilateral are congruent, then it is a parallelogram. And 4, if the diagonals of the quadrilateral bisect each other, then it is a parallelogram. So if our diagonals bisect each other, we can prove that this is a parallelogram. And then condition 5, if one pair of opposite sides of a quadrilateral is both congruent and parallel, so we have a single set that is both congruent and parallel, then the quadrilateral is a parallelogram. So let's revisit these. So condition 1, we need opposite sides congruent to show that it's a parallelogram. Condition 2, supplementary consecutive angles to show it's a parallelogram. Condition 3, opposite angles congruent to show it's a parallelogram. Diagonals that bisect each other to show a parallelogram. And then condition 5, one pair of sides that is both parallel and congruent to show that we're dealing with a parallelogram. So based on the markings in these pictures, can we determine whether or not each of these figures is a parallelogram? Well, in the first example, we've got congruent marks here and here, and then these two pieces are congruent here. So yes, because the diagonals bisect each other. In the next one, we've got a pair of parallel sides, but a different pair of congruent sides. So this would be no. We would need one of the pairs of sides to be both parallel and congruent for this to be condition 5. Well, looky here. Here we have parallel and congruent, parallel and congruent. This is condition 5. So yes, by condition 5, we are good to go here. Or we can say one pair of sides parallel and congruent. Here we want to know if we can prove that the quadrilateral is a parallelogram based on the information given, and then explain. And to explain, we're going to go ahead and use a proof. So the first step of this proof would be to restate the given, like any other proof. So once we've stated the given, we should then start to look and see where we can make some connections. Well, if we notice carefully here that these two angles here are supplementary, they add up to 180. So that'll be the next step we use. We're going to state that. So in step 2, we're going to say that the measure of angle A plus the measure of angle D equals 180. And we did this through angle addition property. From there, we can pretty much say, since we know they add up to 180, that angle A and angle D are supplementary. And that's just definition of supplementary. Two angles that add up to be 180 are supplementary. So definition of supplementary. From there, we shouldn't recognize that these would be same side interior angles. because of that, we can state that in this case, AB should be parallel to DC by the converse to same side interior angles theorem. All right, and so now we've got parallel sides here. Well, we've got parallel sides. We've got parallel sides. Oops, that's not the marking for parallel. We already know that the sides are congruent because they're both measure 5. And so we have parallel sides. We know that both of the sides are 5, so they're also congruent. Well, that's condition 5. So we have enough information now to show that this is a parallelogram. So ABCD is a parallelogram. And we know this by definition of parallelogram. You can also say condition 5 here. And if you can't remember the conditions, exactly the number, you can go ahead and write out one pair of parallel sides and congruent sides. That'll work as well. Here, they want to know if we can prove that this quadrilateral is a parallelogram based on the information. So they tell us that angle Y is 49, angle Z is 131, and angle W is 49. So let's go ahead and just label this 49, 49, 131. There's actually a couple of ways to do this one, but we'll go ahead and take the easy route. First step, restate your given. So we're trying to prove that WXYZ is a parallelogram. Angle Y equals 49. Measure of angle Z equals 131. Measure of angle W equals 49. And that's our given step. From there, we should recognize that if we add up these two angles, so in this case, the measure of angle X plus the measure of angle Y, it's going to equal 180. We should also recognize that if we add up these two angles, so the measure of angle X plus the measure of angle W, it's also going to equal 180. And we know this because of angle addition. So now that we know that those are both adding up to 180, we can go ahead and say that angle X and angle Y are supplementary. We also know that angle X and angle W are also supplementary. That's just definition of supplementary. From there, well, we've now showed that we have consecutive angles are congruent. Sorry, they're not congruent. Consecutive angles are supplementary. They add up to 180. So we can actually say here, because of one of the conditions, we know that X or WXYZ is a parallelogram. And we know this because of condition. We can say condition. Which condition is this? Condition number 2, where consecutive angles are supplementary. If we wanted to, we could have actually taken the supplementary step for step 3, then went and talked about the converse to same side interior angles, and then proved this using that by definition of a parallelogram. But in this case, I kind of took the short route, and I said condition 2 tells me that I can prove this way, so I'm going to use it and make things easier. Here they tell us that EF is congruent to GD and DE is parallel to FG. Prove that DEFG is a parallelogram. Well, in this case, this doesn't satisfy any of the conditions right off the bat, and I don't really see a connection we can make here. So this one actually can't be done. So we say no, or not enough info. Because this could be a parallelogram or it could be a trapezoid, and you'll see what I mean later in the chapter. All right, question 4, telling us here that the angle ALN is congruent to DNL and ANL is congruent to DLN. So what they're telling us is that these little diagonal angles created here are congruent. Little diagonal angles are congruent. And they want us to prove that this is a parallelogram. And we can actually do this. It's not going to use one of our conditions. It's actually going to just use the property of being a parallelogram. And I'll show you what I mean. So let's start by restating our given. So first step is to restate your given. ALN congruent to angle DNL, and then ANL congruent to angle DLN, and that's given. If we look carefully, we should notice that these are actually alternate interior angles. Because of that, I can now say that AN is parallel to LD, so I'll use that there, but then I'm going to do the similar thing here where AL is parallel to ND. And both of these are done by the same idea, converse to alternate interior angles theorem. So we're proving parallel lines by using the converse to AIA. So what happens is this is parallel to this, and this is parallel to this. By definition, these opposite sides are parallel to each other, which makes it a parallelogram by definition. So in this case, land is a parallelogram, or LAND. And this is just the straight up definition of parallelogram. Here they tell us that triangle TRS is congruent to RTW. Can we prove that RSTW is a parallelogram? Well, yeah, we can. We've got congruent pieces here, so we just got to make sure we set everything up. So before we start the proof, if we start marking things, so like the triangles are congruent, but think about corresponding pieces. So that means that TR here should be congruent to itself. TS would be congruent to RW, and SR would be congruent to TW. So we're going to let that information guide us. So we're going to start with our given. TRS is congruent to RTW by the given. Then we should be able to, like I said before, match up congruent sides. We can match up angles if we wanted to in this case. There's a lot of things here we could do. And I marked the sides, but you could also go the route of marking the angles. So there's a lot of different routes to go here. Let's say I wanted to use condition 1, because I haven't used condition 1 yet. So we're trying to prove opposite sides congruent. So we've got that. So we can say that In this case, I don't need all this extra markings. It's kind of distracting, so we'll take it out of the picture there. So we'll go ahead and say that SR congruent to TW, and then RW congruent to ST. And that'd be CPCT and CPCT, corresponding parts of congruent triangles. So we've got those matched up. Well, that right off the bat tells us that RSTW is a parallelogram, and we know that because opposite sides are congruent, so that would be condition 1, or we'd say opposite sides are congruent. If we wanted to, we could have proven the alternate interior angles like the previous example, and then use parallel lines in the converse, and then it would have been exactly like the fourth proof we saw, but I chose to do this one a little bit differently. All right, so let's move on to the next part. All right, in this example, we're looking for what values of the variables must A, B, C be a parallelogram. So basically, they want you to treat it as A, B, C, D. The shape is already a parallelogram, so you have to use your properties to solve for the variables. So with it being a parallelogram here, I know that consecutive angles should be supplementary. So that means these two angles should add up to 180. So 3x plus 10 plus 8x plus 5 should equal 180. Go ahead and combine some like terms. We've got 11x plus 15 equals 180. We'll subtract the 15, so I've got 11x equals 165. Divide by 11, I get x equals 15. Once I know what x is, I can plug it back into the original problem for either angle, but I'll use this one. 3 times 15 is 45, plus 10 is 55. So these two angles should be supplementary as well. So 5y plus 55 equals 180. Subtract 55, you get 5y equals 125. So y has to be 25 in this case. Here, same idea. We want to pretend to ABCD, or basically accept that ABCD is a parallelogram and solve accordingly. Well, we know that opposite sides in a parallelogram are congruent, so we can take 2y plus 2 equals 3y minus 9. We'll solve this. We'll bring the 2y over. You get y. Add the 9 equals 11. So y is 11. Once we know what this y is, we're going to plug it in right here. So that means that this side length has a length of 15. Then we can set these two pieces equal to each other. So 3x plus 6 equals 15. Subtract the 6. 3x equals 9. And divide by 3. X equals 3. So our answers are 3 and 11.